We are taking R.d. Sharma Class 12 Solutions, Chapter 19, Exercises 19.25, Indefinite Integrals. Now the next one is log x plus 2 divided by x plus 2 whole square. So what all options do we have to solve this? We can take this x plus 2 as t, try to make it minimized, or we can take t equals to log x plus 2. What do we get? dt by dx will be 1 by x plus 2, and then x plus 2 will be simply 1, the differentiation of this. So what we can do here is we can separate these terms out in order to meet this assumption. That means we can write this as log x plus 2, 1x plus 2 because it is square. So 1x plus 2 here, 1x plus 2 here. And dx is already there with us in the numerator. So this dx by x plus 2, which is dt, and wherever x plus 2 is there, how do we write it? Because we have taken t equals to log x plus 2. So we need to know certain things about our logarithm and exponentiation. So we got log t by t. T goes up, t raised minus 1. So we can use the formula to solve it. But rather than doing this, let's make it more easier. You know that log base EA equals to B, that means E raised B equals to A. That is the standard result of log. That is how the log and exponential or exponents are related also. So E raised T will be equals to x plus 2 by the same analogy. So what we will do here is log base E x plus 2. If you place this x log, let me write it again, because x plus 2 we have got as e raised t. So if you write this log base e x plus 2 as e raised t, e gets cancelled, you already know that, and it's just t will remain. So only t will remain. So in place of log t, t will come because of the explanation I gave you, and the denominator x plus 2 will come as e raised t with the same kind of expression. Now this integration will be done, and again we have to do the same thing. E raised t has to be brought up, that is upstairs, and we need to write e raised t as e raised negative t. So t into e raised negative t dt. So we'll take the algebraic expression first, t integration of e raised minus t dt minus integration of d by dt of t. We have taken u as t and v as e raised minus t. Then the integration of e raised minus t again, and this whole with the dt. So t, e raised minus t differentiation integration always will be e raised minus t only. And then differentiation of negative t will be negative 1. So this will be negative e raised minus t. So just replace integration of e raised minus t as negative e raised minus t. And d by dt of t will be 1, e raised minus t. Again we have to integrate it. So since a negative have already come, we have made it as plus. First one will be negative t e raised minus t. Then we have e raised minus t again with a negative sign, plus constant of integration. Better is to take negative e raised minus t outside. So when you take negative e raised minus t outside, t will remain here and 1 will remain here. So t plus 1. This is your final answer with a constant of integration. But we need replacement as well, because we cannot keep like this. So just place this t as log base e x plus 2, and wherever t is there, you know already what to write, and wherever other things are there. So this will be e raised minus t I have taken in the denominator now. So t plus 1 is log x plus 2 plus 1, and e raised t from here, it will be x plus 2. Now you can write it like this, or you can make it more simpler. There are two terms, log x plus 2 and 1. So log x plus 2 divided by x plus 2 is one term, and 1 by x plus 2 is another term. And there is a negative also, please remember. So I am writing the final answer, negative log x plus 2 divided by x plus 2. And negative will come with this one also, negative 1 by x plus 2 plus constant of integration. Okay, this is how you have to do it. There are certain log things and exponential things which I explained you that will be used here immensely. And that's how you have to do this with all this English-like language, like taking t as the first function, e raised minus t as the second function, and the substitution also. x plus sin x divided by 1 plus cos x. So do you find anything which can be done? We know that 1 plus cos x can be written in some way. So this x divided by 1 plus cos x plus sin x divided by 1 plus cos x. And then 1 plus cos x and 1 minus cos x, we have the direct result. That means 2 cos square x by 2 is your what? 1 plus cos x. Similarly, 1 minus cos x is 2 sin square x by 2. So we can write this 1 plus cos x as 2 cos square x by 2. So 1 plus cos x is simply 2 cos square x by 2, which I am writing right now. Now sin x can be written in form of this x by 2 form, because sin 2 theta is what? 2 sin theta cos theta. Sin 2x is 2 sin x cos x. We can write this as 2 sin x cos x by 2 cos x by 2. And then denominator again 2 cos square x by 2. Now this 2 in the denominator can be taken outside if you want, or you can just keep it and cancel the second terms 2. It's up to you. Cos square x by 2 can be taken up. It will be sec square x by 2. Here what will happen? 1 cos you can cancel. 1 cos x by 2, if it cancels, sin x by 2 and cos x by 2 will give you tan x by 2. So this will be tan x by 2. Don't worry about the constants. You will manage it. I am sure about it. Just concentrate on the different trigonometric terms. So tan x by 2 has come. Now we need to integrate these two. Log this tan x by 2 has a direct result. Alright. So x sec square x by 2, that has to be integrated, and tan x by 2 has to be integrated separately, because tan x by 2 has a direct result. Let me write the direct result, which is log modulus of sec x by 2. And then x by 2 has to be, because we are doing integration and the other part has to be integrated. The first part has to be integrated and the inner part has to be differentiated and kept in the denominator. So half is in the denominator. This we will use the formula again, x sec square x by 2. X first, then integration of sec square x by 2. We are taking u and v as the first function and second function. D by dx as of x, then integration of sec square x by 2. This end and then the dx. X sec square x by 2 is what? It's tan x by 2. Now what is the x by 2 differentiation? It will be half in the denominator. Minus d by dx of x will be 1. Sec square x by 2 will be tan x by 2 again. And tan x by 2, the x by 2 will go with the differentiation, half will come, that will go in the denominator. Now again integration of tan x by 2 has to be done. So same thing what we have done, integration of tan x by 2, which is the last term. We already done log modulus sec x by 2. So log modulus sec x by 2 will come with a half. And there are plenty of things which we have to add, that is the numbers on all, half and 2n, that you know already how to do that. And we have log modulus sec x by 2. So now you can just cancel these two out, because we have a half outside in the previous explanation, the second step. When you take half this, it will cancel out all the denominator. All the half in the denominator will get cancelled. And other things remaining, only log sec x by 2 and minus log sec x by 2 will remain, so it will get cancelled. And the final result will be only x tan x by 2 and plus constant of integration. That will be your final answer. Now this is how this has to be done. Alright. Now log base 10x. This is question number 25. Now the question may vary depending upon your edition of book which you are doing. So log base AB can be written as what? First log B divided by log A. Now the base has changed to E. Same thing we have to do here. We have to write this log x divided by log 10, and please remember the base is E. Log 10 is constant, so you don't have to worry about it. You will just keep it in a temporary bag. Log x we have to integrate. Now assume that it's multiplied by 1 and the first function and second function will be taken accordingly. That is log x integration of dx minus integration of d by dx of what? Log x and integration of dx. This is with dx. So log x, integration of dx will be x. Here also log x differentiation. Integration of dx will be x only. D by dx of log x will be 1 by x. X gets cancelled. Only 1 will remain. So integration of dx has to be done, which is finally x only. And then you can just add a constant of integration. That's your final answer. Just by a trick or the log relationships, you see how easy it has become. There is a log 10 also, so we'll include that log 10 here. X you can take common, it will become log x minus 1. That will be more easier to comprehend. So this is how this needs to be done. Now if you remember, we have already done e root x, and I explained you why we have to take, what to take, and how it will benefit us. So we'll apply this cos root x, multiply numerator denominator by root x. So when you take t equals to root x, dt by dx will be 1 by twice root x. That is the standard result, you already know that. So 2 dt will become dx by under root x. 2 dt will be dx by under root x. When you integrate this, dx by root x is twice of dt. 2 you can take outside, dt will remain inside. And this under root x has to be kept as t. Cos, then root x will be t. So t cos t, twice of t cos t. We have to do the integration of t cos t actually. So t we take as the first function, then integration of cos t minus d by dt of t, and then integration of again cos t. Then whole of these has to be integrated after multiplication with the d by dt. T, what is cos t integration? It's simply sin t. d by dt of t will be 1. Cos t integration is again sin t. Then we have to integrate it again. So there is an integration here. Minus, because sin t will be negative cos t. So plus cos t plus constant of integration. In place of t, now you have to write under root x. That's you have assumed. So root x sin root x plus cos root x and plus constant of integration. Please remember, there is a 2 also in front, so multiply it by 2. That will complete your answer. So this is the reference. This question, if you have done e raised root x, that will be very easy for you. Now this kind of question we have already done in the differentiation when we were learning that. We will take cos inverse x as u and x by under root 1 minus x square as v, or 1 by under root 1 minus x square as v. You know why? Because 1 minus x square, if it is equated to t, the differentiation dt by dx will be equal to negative 2x. That is, if you take this negative 2 here, it will be dt divided by negative, its 2 will come in the denominator. So we have x dx. So cos inverse x we are taking as the first function. Integration of x divided by under root 1 minus x square. Then minus integration of d by dx of first function, which is cos inverse x. And then the integration of x by under root 1 minus x square. So this x by under root 1 minus x square has to be kept twice. So we'll do this separately. Under this integration of x by under root 1 minus x square will be done separately because it's twice. So integration of x divided by under root 1 minus x square. 1 minus x square was already being taken as t. X ds is, there is a slight change you have to do. I have committed a small mistake here. Dt, negative dt by 2 will be x dx. So dt by under root t will come, and this will be, you just call it as t raised half. It goes to up and it will become t raised minus half. You can write t raised minus half plus 1 divided by negative half plus 1. It will be t raised half by half. So this 2 will go up, and as I told you, it is negative dt by 2. There is a slight mistake I told you. The dt by 2 gets cancelled. Since t under root t will come, that is the final thing. Only minus because of 2 gets cancelled. And what was t? T was under root 1 minus x square. So minus cos inverse x and under root 1 minus x square with a negative sign. So negative we have kept outside. Same thing here. Minus. So I'll do it separately and then we'll fix the answer here. What is cos inverse x differentiation? It's negative 1 by under root 1 minus x square. And what was the integration here? It was negative under root 1 minus x square. Now this negative will become positive. Under root 1 minus x square, because it is in the numerator also, denominator also, we can cancel it. Only integration of dx will remain. So only x will come plus constant of integration. That's your final result. So the question seems to be typical, but once you are in practice and you understand what to be taken as the first function, what needs to be taken as the second function, it will be quite easier for us. This is the way you have to do. Please remember, differentiation will be this dt by negative 2 will be equal to x dx. That you have to keep it here. And integration of x by under root 1 minus x square dx has to be done separately because it will need some effort. Now we have log x divided by x plus 1 whole square. This is with the dx. First function will take it as log x. And then the integration of 1 by x plus 1 whole square. Minus integration of what? D by dx of log x. And then integration of 1 by x plus 1 ka whole square. Dx. And this whole with a dx. Integration of 1 by x plus 1 whole square has come twice. So 1 by x plus 1 whole square, this x plus 1 whole square goes up. If you just take t equals to x plus 1, that will be easier. dt and dx will be equal. So basically you are integrating 1 by t square because t was taken as x plus 1. If you just square it, x plus 1 whole square, it will be t square, 1 by t square. And dt is equal to dx. So this t negative 2 will go up. Integration will be taken t negative 2 plus 1 divided by negative 2 plus 1 plus a constant of integration. Of course, that we will include later. So minus 1 by t has come. And what was t? Minus 1 by x plus 1. So 1 by x plus 1 whole square integration has given us negative 1 by x plus 1. So now I am replacing this integration with negative 1 by x plus 1. So negative multiply x plus 1 in the denominator. D by dx of log x will be 1 by x. This already has been done. It is negative 1 by x plus 1. Negative goes outside, so it will become positive. So 1 by x plus 1. Now x into x plus 1. These are two factors actually in the denominator. Now you can use the partial fraction which we have already done in the previous exercises. You can do that. Or you can make it as a perfect square after multiplying x with x plus 1. So I am writing negative log x by x plus 1. The second term I will do it separately, then fix it here with a constant of integration. What is 1 by x into x plus 1? It is x square plus x. Now x square plus x, what is the coefficient of x, which is 1? Just divide it by 2, square it, add it, subtract it. So 1 by 2 whole square minus 1 by 2 whole square. A square plus b square plus 2ab. So x plus half whole square has come and minus half whole square remains. So you can just write it as integration of 1 by x plus 1 whole plus x plus half whole square minus half whole square. And you already know the formula directly. 1 by 2a log x minus a by x plus a. Because this is simply integration of 1 by x square minus a square. So integration of dx by x square minus a square will give us 1 by 2a log x minus a by x plus a, which has to be inside the modulus sign. You cannot have a negative inside the log. So we'll write this in terms of the formula. 1 by 2a, a is half. A is half and x is x plus half here. Log x minus a, x plus half minus half, and denominator x plus half plus half. This gets cancelled. This will become log. This gets cancelled. Log x by half plus half is 1. So log x by x plus 1. Now you can just write it as log x minus log x plus 1, because log a by b is log a minus log b. But you don't need it. Here you don't need it. You can just directly keep it as log x by x plus 1. So minus log x by x plus 1. This whole we have already got. So let me write it here. Log x by x plus 1, both in the modulus sign. So let me write it clearly, okay, so that we just get the glimpse of the answer which will come. So integration of log x by x plus 1 whole square shall be negative log x divided by x plus 1 plus log modulus of x by x plus 1 plus constant of integration, and this is your final answer. How are we going to do it is in front of you. So previous exercises will really help you in answering this. This question is a different type of question. We will attempt it in the next discussion. Till then, thank you so much and take care of yourself.